Okay, let's look at the product rule and the quotient rule for derivatives. Alright, first, product rule. Alright, so product rule is basically we want to take the derivative of the product of two functions. So let's say f of x times g of x. Right? If you take the derivative of that, you will have to take the derivative of the first guy. So it's going to be f prime of x, then multiply by the second guy without taking the derivative, plus, right? Then you have the first guy without taking a derivative, multiply by derivative of the second guy. So it's going to be g prime of x, right? So we would have to take the derivative one at a time, right? So that's the product rule. Right? So let's look at an example here. Right? So here we have two things multiplied together. So you see that this first guy, you can think of it as f of x. Right? Here, this is our second guy, g of x. Alright, so let's take the derivative using the product rule. Alright, so y prime. Right? So we have to take the derivative of the first guy, which is going to be, right, derivative of 1 is 0 since it's a constant. Derivative of x is 1. Right? And the derivative of negative x squared would be negative 2x. Alright? Then multiply by the second, so e to the x. Right? Plus. Right, leave the first guy alone, so it's going to be just copy the first guy. So 1 plus x minus x squared. Right? Then multiply by derivative of the second guy. But the derivative of e to the x itself, so it's you're going to get e to the x again. Alright, we can simplify a little bit that we're done with the derivative. So since e to the x is in common, so we see that you have e to the x right here, and e to the x is right here. Right? So we can put we can factor out e to the x right out here. Right? Then we can just collect other terms here. Alright, so we have, there's 1 here, right, and there's another 1 here. So combined together, you're going to get 2. Alright, and we have a negative 2x here, and there's a positive x there. Combined together, you get negative x. Alright. Then we still have a negative x squared here. So we would have to put the negative x squared there. Alright. So this is the derivative of this given function. Alright. Let's look at the quotient rule. Alright. Quotient rule is the derivative of the quotient f of x over g of x. Alright. It's going to be a quotient, but the numerator is very similar to product rule, except that it's going to be a negative sign there. Right? So it's going to be take the derivative of the top, which is f prime of x, times g of x, minus top guy without taking a derivative, multiply by derivative of the bottom, so it's a g prime of x, right, divided by the denominator squared. So you have a g of x, then you have to square that. Alright, so that's the quotient rule. Alright, so let's apply this to find the derivative of this rational function 3x minus 4 over 2x plus 3. Alright. Right, so you can think of it as you can see that the top guy, this guy is our f of x, right? And this guy 2x plus 3 is our g of x, right? Then we want to take the derivative, right? So y prime is going to be equal to, so it's going to be a big fraction, so we have that. Right, I would do the bottom one first, because all you have to do is just copy the original denominator to x plus 3. Then you just have to square that. Alright, so that's easy enough. Alright, then derivative of the top, which is 3, and times the bottom, so it's going to be 2x plus 3. Alright, so minus sign here. Top, which I just copy the original numerator, which is 3x minus 4. Alright, then multiply by derivative of the bottom, which is 2. Alright, and once you multiply out, what we get is, let's see, right? If you distribute 3 to 2x, we get 6x. Alright, if you distribute 3 to 3, we get 9, so plus 9. Alright, then if we distribute 2 to 3x, you get 6x, but we have a negative sign, so it's going to be a minus 6x, right? And then if you distribute 2 to negative 4, that's negative 8, but there's a negative sign, so it's going to be plus 8, right? And the denominator looks nice, so I'll keep that. So it's quantity 2x plus 3 squared, right? Then we can cancel. There's a 6x here, minus 6x. You can cancel that out. So then just combining 9 and 8, so you would have 17 on top, and divided by quantity 2x plus 3 squared. Right, so this is the derivative of the rational function we're looking for. Alright, I would like to go over another example which actually requires both rules. Alright, so let's do that. So here's an example. Alright, so y equals t times natural log of t over e to the t. Alright, so looks like we have quotient, so you can think of this right here is the top guy, f, right? Or we probably should say f of t, right? This e to the t is the bottom guy, so it's a g of t, right? So first, let's follow the quotient rule to find the derivative. So y prime is equal to, alright, so first thing is square the denominator, so we can do that. So you have a e to the t, alright, so I'm going to go ahead and square the denominator. Alright, now we have to take the derivative of the top, but the numerator is a product by itself, so we have to use a product rule there. So derivative of the first guy, which is t, so which is 1, plus times second guy is natural log of t, plus first guy is t times the derivative of natural log of t, which is 1 over t, right? Multiply by the denominator, so I have to put the parentheses around, so you have e to the t, right? Then minus right? So top guy is t times natural log of t, then multiply by derivative of the bottom, but derivative of e to the t with respect to t is e to the t again. So we have that. Right? Then try to simplify as much as possible. Right? So you have e to the t here, and also there's a e to the t square there. So we can cancel that. So we can cancel e to the t here, e to the t here, and one of the e to the t cancel out. Right? Then you can see that the t on top, t on the bottom, you can cancel that. Right? So when you clean it up, you will get this. Right? So you have a big fraction. Right? You have e to the t on the bottom, because one of the e to the t is already canceled out. Right? And what's left is, let's see, we have natural log of t here. Right? So we put the natural log of t. Right? And don't forget there's still 1 here. Right? So it's going to be plus 1. Oops. Right? Plus 1. Right? I try to write in blue. Alright, so plus 1. Right? Then you have minus t times natural log of t. So minus t times minus t times natural log of t. Right? So we have that. And if you want, you can combine natural log of t, this guy, and t times natural log of t, because both have a natural log of t. So you can probably write it as, right, e to the t on the bottom. Right? So both have natural log of t, so I'll just put the natural log of t factored out. So from here you get 1, and from here you have negative t. So, right, then you have a plus 1, so plus 1 right here. Right? So this is the derivative of the given function, where we need to apply both product rule and the quotient rule. All right, that's it. I hope that this was clear.